Oh, hi there. Hope everything is going well with yourselves and your families. And I also need to get a new intro for these videos, but whatever, it's all good. So again, we're going to continue our study of gases in the atmosphere, again by looking at some more gas laws and equations that we can apply to systems that have gas in it. So we've done things like look at the relationship between temperature and volume, which was Charles' law. We looked at the relationship between pressure and volume, which is Boyle's law. Then we looked at the relationship between pressure and temperature, which is Gay-Lussac's law, and then we combine them all and combine gas law. The last sort of law we need to deal with is the ideal gas law. And the first thing you might be wondering is what an ideal gas is defined as. It turns out that an ideal gas is just a gas that obeys all of the gas laws and equations that we've been studying. Okay, just to recap, these are all of the equations that we've looked at so far. So we looked at Boyle's law, Charles' law, and Gay-Lussac law. The last thing we need to sort of consider is Avogadro. So remember, Avogadro was the one who gave us that Avogadro's number, which is 6.022 times 10 to the power of 23 units per mole. So what we need to keep in the back of our minds is the fact that the amount of gas we have, so whether that be the volume of the gas or anything like that, depends on the amount of gas that we have. And in chemistry, we equate amount of something to moles of something. So hopefully you remember that 1 mole of any gas is going to occupy 22.4 liters. So obviously, the volume of the gas, which is usually given in liters, is going to be determined by the number of moles. Okay? So taking that into consideration, we can come up with this equation here, which is PV equals nRT, which pretty much allows us to take our amount of gas in moles, which is N, and equate it to its pressure, its volume, its temperature, and that R term is actually a constant for all gases. And it's usually given as that 8.31 number, but if we're going to use the 8.31, we have to ensure that our units of pressure are kilopascals, our units of volumes in liters, and of course our temperature is in Kelvin. So remember, temperature must always be in Kelvin for any one of these type of gas laws, okay? Okay, so that's the new equation for us to memorize, PV equals nRT. Let's look at a few examples, and this is on page 45, by the way. So if we look at question number 2, and I'm skipping question 1, because question 1 just involves you writing down the different values of R from page 45. So question 2 says an almost empty natural gas storage tank contains 2.65 kilograms of methane at 600.5 kilopascals and 18 degrees Celsius. What is the volume of the storage tank? We're told here that 1 atmosphere equals 101.325 kilopascals. Okay. So this is, again, question 2 on page 46. I'm just going to do it on a different page of paper. Okay. So remember, with this equation, it's PV equals nRT. So we need to identify all of these variables. So P, V, N, R, and T. So the first thing that we can write down is our temperature, which is 18 degrees Celsius. We have to have the temperature in Kelvin. So remember, to convert degrees Celsius to Kelvin, we add 273. So 18 plus 273 is going to give us 291 Kelvin. Okay. Our pressure is given in kilopascals. So we'll put that as 600.5 kilopascals. Our volume is what we're trying to find. So we'll put a question mark. Okay, and R is a constant. And because we were given our pressure in kilopascals, we're going to use the 8.31451. Okay, and the units for that are kilopascals times liter divided by moles times Kelvin. Okay, so the last thing we need to find is N. Okay, so remember N is going to be our number of moles of methane gas. So we have 6.25 kilograms of methane gas. So what we're going to do is we're going to have to, so remember the number of moles is going to be mass divided by molar mass. So that's going to be 2,650 grams. Okay, and the molar mass of methane, that's going to be 12.01 plus 4 times 1.01, 16.05 grams per mole. Okay, so once we divide 2650 divided by 16.05, that's going to give us 165.11 moles. Okay, so now we can fill in what N is. It's 165.11 mole. Okay, so again we're trying to find volume. So if we rewrite our equation, PV equals nRT, right? We want to find volume. So to get volume by itself, we just need to divide both sides by P. So volume is nRT divided by P. So we just plug our numbers in. So that's 165.11 moles multiplied by 8.3145 kilopascals times liters divided by moles times Kelvin times our temperature, which we said was 291 Kelvin. Then we divide this entire term by our pressure, which we said was 600.5 kilopascals. So Kelvin cancels out with Kelvin, mole cancels out with mole. This kilopascals cancels with that, so we only have liters left, which makes sense. So our volume is going to be 165.11 multiplied by 8.3145 multiplied by 291 divided by 600.5. That's going to give us a volume of 665.26 liters. Okay. Yep, and the answer key here is telling us that it's 666 liters. So that would so the exact answer you get is going to depend on where you rounded, but as long as you show you're working and get something that's in the ballpark, you know you're right. So if you had rounded up some of these numbers, it would have changed your final answer. But we got 665.26 liters instead of 666 liters just because of the numbers we used. Okay, so let's do another example here. So if we look at question 3, okay. So question 3 says an average bungalow contains 700 cubic meters of air. How many moles of air does this correspond to if the temperature is 20 degrees Celsius and the pressure is 100.5 kilopascals? Okay, so this one's going to be a little bit more complicated. Let's start working on that one. So if we look at question number 3 now, we have to identify all our variables again. So remember, we're going to be using PV equals nRT. So we need to identify P, V, N, R, and T. So we're told that the pressure is 100.5 kilopascals. Okay, we're told that the volume of air is 700 meters cubed. Okay, we need to convert that to liters in order to use the gas constant. So we're told that 1 cubic meter equals 1,000 liters. So we're just going to add 3 zeros to that number. So that's going to be 700,000 liters. Our number of moles is what we're trying to find. We're going to use the 8.3145 constant. And remember, the units of that is kilopascals times liter divided by moles times Kelvin. And the temperature is given as 20 degrees Celsius. We have to have that in Kelvin, remember. So 20 plus 273 is going to give us 293 Kelvin. Okay, so we're trying to find N, so we can just we can get N by itself by dividing both sides by RT. So we can say PV divided by RT equals N. That would be 100.5 kilopascals times 7,000 liters divided by 8.3145 kilopascals times liter divided by mole times Kelvin multiplied by 293 Kelvin. Kelvin cancels with Kelvin. Liters cancels with liters. Kilopascals cancels with kilopascals, leaving only moles. So we would then type all this into our calculator to find N. That would be 100.5 multiplied by 700,000. Oh yeah, so this should be 700,000. So 700, 1, 2, 3. 700, 1, 2, 3. Yeah, divided by 8.3145 times 293. Okay, and then when we punch it into our calculator, we get number of moles equals 28877.5 moles. And the answer in the answer key is a little bit different, just depending on the numbers you use, but that's how you work it out. If you had rounded earlier or later, you would have gotten a slightly different number, but once you show us the working, it's all good. So a few things to note with these types of questions. You always have to ensure that your temperature is in Kelvin, and you always have to ensure that the units of pressure and volume correlate to the gas constant you're going to use. So if you're going to use R equals 8.3145, since those units are kilopascals times liter divided by mole times Kelvin, your pressure has to be in kilopascals and your volume has to be in liters. Okay, if you were given your pressure in atmospheres instead of kilopascals, you can either do a conversion or you can use the R equals 0.0821 R. That's pretty much it for this video. Now you can try to check your understanding. Have a good one.